Okay, well, the associated problem on your document asked if you have this beam, how much of your mass is concentrated between, well, how much of your mass is concentrated within delta r, small delta r interval of that beam, small delta r length of that beam. Okay, if the total mass of the beam is 100 grams, and the beam has whatever length, if the beam extends in both directions, as it might well do, right here is a delta r interval, and the mass occurs here and here. Okay, if the 100 grams is equally distributed between this end and this end, then you need both of these intervals to get delta r over 40 of the total mass. It's just a simple proportion. Okay, take delta r over 40, that's the portion of the mass in this interval compared to this part of the beam. Now if you got this part of the beam, well, same is true over here, so you still have within this delta r interval around the center of the beam, delta r over 40 centimeters times 100 grams. So you want to reconcile that idea. And if all the mass is on this side, then the whole 100 grams is on this side, so you still have delta r over 40 centimeters times 100 grams. Either way, that's the amount of material, that's the mass of the material in a delta r, any delta r interval, if the mass is distributed uniformly, as is the hypothesis here, as is the condition given here. Okay, so, well, if we take some distance r to tell us where that interval is, we're going to call that r star. Get used to doing that now. Okay, so the speed within the given interval would be omega times r star. Okay, because if we multiply the r by the angular velocity, the radians and all that, as we've seen here, we do get the speed of a point. So if r star is a representative distance from the origin within this delta r interval, wherever it is, then this is our speed, so our kinetic energy is 1/2 mv squared, which comes out to be this. If we want the total kinetic energy of the whole bar, we just integrate this expression from 0 to 40 centimeters. Now we'll do more of that. We did that kind of quickly at the end, but you want to think about that so that when we do it a little more in detail, you'll understand it and you'll understand how the integral is built up.